everyone, so in this video I'm going to continue chapter 3.2 periodicity, but in this video I will discuss learning outcome C, D and E. That's mean by the end of this video you should be able to define what is isoelectronic, and then you should be able to compare the radius of isoelectronic species, and lastly you should be able to analyze the variation in ionic radius for period 2 and period 3. Let us start with the definition of isoelectronic species. Okay, so what is isoelectronic species? Okay, atoms or ion with the same electronic configuration are known as isoelectronic atoms or ions. Okay, so that's mean isoelectronic species ni adalah species ataupun atom ataupun ion yang ada same electronic configuration. That's mean when we write the electronic configuration, dia punya electronic configuration start daripada 1s sampai habis tu sama, exactly the same. Okay, so the word iso means same lah. Okay, and electronic here mean electron. Okay, so macam mana boleh sama electronic configuration? Nak sama electronic configuration, that's mean dia punya electron dia tu yang sama. Okay, alright, so isoelectronic species is a group of atoms or ion with same electronic configuration, which is the same number of electron. Okay, so macam saya cakap tadi lah, dia adalah satu group of atom. It can be atom or ion lah, tapi dengan syarat dia punya electronic configuration dia sama. Okay, macam mana electronic configuration boleh sama? Sebab dia punya number of electron sama. Okay, so let us look at this electronic configuration below. Okay, so ada 4 electronic configuration. What I'm going to focus on adalah ini. Okay, kamu boleh tengok F minus, dia punya electronic configuration dia jadi 1s2 to s2 to pc. Okay, kenapa jadi 2pc over here? Sebab sini asalnya initially 5 electron here. Okay, but minus 1 tu maksudnya kita add 1 electron. Okay, so that's mean 2p5 become 2p6. Okay, so inilah electronic configuration for F minus. And then let us look at electronic configuration for O2 minus. Sama juga, O2 minus asalnya 2p4, but then we add 2 more electron, so it become 2p6. Okay, if we compare this electronic configuration, sama. Okay, and then sodium. Okay, sodium dia walaupun dia charge positive, but they are isoelectronic to F minus and O2 minus, disebabkan bila charge positif tu maksudnya kita remove electron. So kita remove satu electron from 3s1, then dia hanya tinggal 1s2 to s2 to p6. So this electronic configuration same as F minus and O2 minus punya electronic configuration. Okay, and lastly the same goes for Al3+. Okay, electronic configuration of Al3+ after we remove 3 electron from the 3s2 and 3p1, we are left with 1s2 to s2 to p6. Okay, so this electronic configuration sama macam atas ni, sama macam yang ini. Okay, alright, and then kalau kamu perasan dekat bawah ni saya ada tulis neon kan. Okay, kurungan neon, still remember? Okay, neon ni maksudnya, kurungan maksudnya ini neon. Kalau kamu refer to your periodic table, ada 10 proton and 10 elektron lah sebab dia neutral. Okay, so bila 10 elektron, so 1s2, 2s2, 2p6. Okay, so this is the electronic configuration for neon. So over here, okay, so kita boleh cakap lah electronic configuration ini actually isoelectronic with neon pun boleh. Okay, and then we can say that F minus, Na plus, O2 minus, Al3 plus ni semua adalah isoelectronic ion lah. That's mean ion yang ada same electronic configuration. Okay, so after kita dah faham what is isoelectronic, then kita nak tengok variation of radius dalam isoelectronic species itulah. That's mean we are going to compare ion yang ada same electronic configuration tapi dia punya size dia jadi lain-lain disebabkan effective nuclear charge dia ataupun shielding effect dia lah. So kita tengok. Alright, so kita start dengan ini, ionic radius for cation ion period 3. Okay, so this is the cation ion, okay, that we are going to discuss. Sodium, magnesium, aluminium and silicon ion. Okay, so semua ni kalau kamu check your periodic table, they are in period 3. Okay, so kita tengok dia, oh dia berada di period 3. Okay, semua period 3. That means kita dah tahu dah lah kalau dalam keadaan neutral, kita tahulah going across a period, size will be smaller. Okay, but that is for atom. Okay, atomic size. This one dia dah jadi ion. Okay, ionic, and tambahan pula dia dah jadi isoelectronic species. So let us check lah dia punya size and so on. Okay, first we need to be able to identify that these ion are isoelectronic species. Okay, so in exam ataupun tak ada exam lah for this one, in your assignment, kalau kamu boleh identify this ion adalah isoelectronic species, you will get 1 mark. Okay, kenapa kamu boleh dah? Sebab dia satu benda yang kamu dapat capai lah. Kalau soalan tu tak bagi tahu, tapi you can determine itu adalah isoelectronic species, that's mean itu satu pencapaian. That's mean kamu layak dapat 1 markah lah for that. Okay, alright, and then kita check electronic configuration dia. Okay, so this electronic configuration adalah untuk ion. That's mean after we remove the electron lah. Okay, so we are left with 1s2 2s2 2p6 for semua ion ni. Okay, so that's why kita panggil dia isoelectronic ion. Okay, sebab dia punya electronic configuration sama. Okay, so now number of electron pun sama lah sebab dia isoelectronic species kan. Okay, and then kita kira dia punya effective nuclear charge. Okay, when we count the effective nuclear charge, it turns out dia punya nilai tak sama. Okay, logik lah tak sama. Kenapa tak sama? Sebab you have to remember, okay, effective nuclear charge, the formula is Z minus S, where Z is proton number. Okay, so although dia punya electron dia sama, but dia punya proton dia tak sama. Okay, so as you can see, sodium ada 11 proton, magnesium 12, 13, 14. Okay, proton number dia tak berubah walaupun dia jadi ion. Proton number kekal. Yang berubah adalah elektron. Okay, so macam mana dia boleh dapat sodium ni effective nuclear charge dia 9? Sebab dia kira macam ni. ZF equal to untuk sodium sodium ion. So there are 11 proton minus with S is electron yang berada di inner shell. Okay, so you have to look here. Okay, 1s2 2s2 2p6. Ada 2 shell dia. Shell 1 and shell 2. So which one inner shell? So automatically yang 1 ni adalah inner shell. Okay, how many electron in that inner shell? Okay, ada 2 electron. So 11 minus 2 equal to plus 9. Okay, so itulah cara macam mana dia boleh dapat effective nuclear charge of sodium ion is plus 9. Okay, so the rest pun sama juga cara yang sama dia buat pengiraan. Okay, so as you can see, effective nuclear charge, the value increasing. Okay, makin meningkat. So kalau kita dah betul-betul faham pada peringkat awal, kita dah faham dah what is ZEF, then kita dah boleh explain this size of ion ni without looking at these notes pun kamu dah boleh explain dah. Sebab kalau effective nuclear charge tinggi, so maksudnya dia punya attraction, okay, attraction between nucleus and valence electron getting stronger lah. Okay, so kena sebut attraction between apa? Okay, so bila attraction between nucleus and valence electron getting stronger, okay, so that's mean size is getting smaller. Okay, so size makin kecil. So that's mean kita dah boleh expect dah sodium ion dengan magnesium 2 plus ion ni. Magnesium 2 plus ion is smaller in size lah. Okay, but if we compare 4 ni, yang mana the smallest one? The smallest one is silicon lah. Silicon is the smallest one. Okay, so kita nak check betul ke tak kita punya explanation. Okay, so jom kita tengok bawah ni. Right, so first their electronic configuration are the same, so they are isoelectronic. Yes, you should be able to state this masa awal-awal kamu buat penerangan tu. Okay, and then cakap lah proton number increases from sodium to silicon ion. Yes, betul. Okay, proton number you can see over here. Okay, and then the effective nuclear charge also increase. Yes, kita dah buat calculation dah tadi. And then the force of attraction of nucleus toward the electron also increase. Yes, sebab ZEF increase, so maksudnya force of attraction antara nucleus dan valence electron tu meningkat lah. Okay, and then bila tarikan tu kuat, that means the electron are pull closer to the nucleus. So before this saya dah cakap, bayangkan kamu dekat tengah ni adalah nucleus. So kamu ada tali untuk tarik elektron. If you pull the electrons very strong, kamu tarik dengan kuat, that means this electron will be macam jarak dia akan jadi lagi dekat dengan kamu. So that means the size is getting smaller. Okay, so we can conclude that the ionic radius decreases from sodium ion to silicon ion. Okay, right, so samalah macam kita interpret tadi. So basically this chapter tak adalah the whole thing kamu kena hafal, tapi macam saya cakap, you have to really understand what is effective nuclear charge. You have to really understand what is shielding effect, then you can macam manipulate your knowledge from there lah. Okay. Alright, so ini adalah extra sikit. Within isoelectronic species, the more positive the charge, the smaller the species. Okay, so as you can see, the charge here, the positive charge is getting bigger. Okay, from +1 to +4. Okay, so bila keadaan yang macam ni, kamu boleh cakap bila makin positif nilai ion tu, makin kecil lah size species tu. Ini membantu kamu bila kamu nak jawab soalan objektif later on lah. Right, so next we want to see ionic radius for n ion, okay, and that n ion reside in period 2 in the periodic table. Okay, so the n ion yang kita akan discuss adalah nitrogen, oxygen and fluorine ion. Okay, so nitrogen N3 minus, ini O2 minus, ini F minus lah. Okay, so bila kita check, dia punya electronic configuration of the ion is the same. That means again, okay, N3 minus, O2 minus and F minus tu adalah isoelectronic ion. That means they have the same number of electron and the same number of electronic configuration. Okay. Alright, so dia punya effective nuclear charge masih berbeza. Okay, sebab bila kita tengok proton number dia lain kan. Okay, so ini saya tunjuk macam mana dia determine Z dekat sini untuk N3 minus. Okay, so there are 7 proton for nitrogen, 7. Okay, minus with inner electron in this case sama jugalah. Okay, kita ada 2 shell only, so that means 1s2 is the inner shell. And in 1s2 there are 2 electrons, so 7 minus 2 equal to +5. So that's why dia dapat +5 over here lah. Okay, so you can do the same thing for O2 minus and F minus. So again, okay, you can see that the effective nuclear charge increases. Okay, so maksudnya attraction between nucleus and valence electron getting stronger. So we should expect the size of F minus to be the smallest one lah. Okay, so let us look here. Dia kata their electronic configuration are the same. Okay, betul. The proton number increases from N3 minus to F minus. Yes, that's correct. And then the effective nuclear charge also increase. Ya, kita dah buat pengiraan. So as a result, the force of attraction between nucleus and valence electron also increases. And then the electron are pulled closer to the nucleus. Okay, so electron tu akan jadi makin dekat dengan nucleus. Okay, so size tu get decreases from N3 minus to F minus. Okay. Right, so over here maybe you can do some correction lah. Okay, so the force of attraction of nucleus towards, okay, valence electron. Please add the word valence tu lah. Okay, alright, and then since ini adalah n ion, okay, so dia kata within isoelectronic species, more negative the charge, the larger the species. Okay, so maksudnya kalau kamu jumpa n ion, okay, and then dia punya charge dia makin besar. Contoh macam ni lah. F minus tak besar sangat. Oh, 2 minus besar lagi. 3 minus lagi besar. So that means we should expect size yang N3 minus tu yang paling besar lah antara yang lain tu. Sebab lagi negatif, lagi besar species tu. Betul lah. Okay, lastly, we want to discuss variation in ionic radius across period 3. Okay, kalau tadi pun kita discuss ionic radius across period 3 juga. Yang this one. Okay, tapi yang ini kita nak discuss period 3 tapi lebih panjang lah. Sebab yang tadi kita discuss sampai silikon je, tapi kita tak discuss yang belakang ni. Okay, so this is the graph, okay, showing the size or ionic radii of ions. Okay, so as you can see, size of sodium ion is the biggest one lah kalau among the cation ion kan. Okay, and then the size is getting smaller. But then, suddenly, the size of P3 minus increase macam over sangat peningkatan dia tu. So kalau nak compare dengan Si4 plus dengan phosphorus, size dia peningkatan yang sangat mendadak. Kita expect sepatutnya makin turun lah kan, tapi tak. Okay, so kiranya dia turun. Lepas tu untuk phosphorus walau dia akan naik and then turun balik. Okay, so ini kita dah explain dah tadi. Okay, kita dah explain kenapa jadi macam tu, sebab dia punya effective nuclear charge dia lah. Okay, so we can look here. Okay, so the effective nuclear charge makin meningkat. So attraction between valence electron and nucleus makin kuat. So size makin kecil. Okay, so done, settle. Okay, and ini pula dia anion. Okay, anion. So kita tengok dia punya electronic configuration. Okay, they are isoelectronic to each other. P3 minus, S2 minus dengan Cl minus ni sebab kita boleh tengok number of electron sama, electronic configuration sama. So they are isoelectronic to each other. Okay, and then if we look at the effective nuclear charge, dia 5, 6, 7. So meningkat. So that's why no wonder lah the size is getting smaller. Okay, size jadi makin kecil disebabkan dia punya ZEF dia makin meningkat. Okay, alright. So kita tak ada masalah dah on these two. But now we want to explain why there is a sudden increase over here. Kenapa peningkatan yang mendadak tu? Okay, why there is a sudden increase from silicon 4 plus to P3 minus. Okay, so let us have a look at the electronic configuration, because from the electronic configuration it can tell us a lot. Okay, so kita tengok dia kata P3 minus 1s2 to s2 to p6 3s2 to p6. Silicon ion 1s2 to s2 to p6. Right. So between these two electronic configuration, apa biggest difference yang kamu nampak? Okay, so kena ingat benda ni dia dalam period yang sama. And dia duduk sebelah-sebelah je silikon dengan fosforus ni. So, tapi apa perubahan ni yang sangat drastik yang kamu boleh nampak? Adalah, inilah kamu boleh perasan tak? P3 minus, okay, ion dia lah, anion dia ada electronic configuration up until 3p6. But for silicon 4 plus, the electronic configuration is up until 2p6 only. Okay, so ada different satu shell dekat sini, ada perbezaan. Okay, so we can say that P3 minus has more number of shells. Okay, so dia ada banyak number of shells. Shell tu, that means saya refer kepada inilah nilai N tu. N tu kita panggil shell pun. Right. So P3 minus have more number of shell compared to silicon 4 plus ion. Thus, P3 minus have greater effect compared to silicon 4 plus. Okay, ingat lagi, kalau kita ada banyak shell, apa yang meningkat sebenarnya? ZEF ke shielding? So sebenarnya bila dia punya shell bertambah, that means shell occupied by the electron bertambah, so maksudnya shielding effect dia makin meningkat. Okay, so over here greater shielding effect. Sebab okay, so kalau kamu ingat, number of shell occupied with electron itu mempengaruhi shielding effect dia lah. Sebab bila banyak shell and that shell is occupied with electron, dia punya repulsion tu akan jadi lagi kuat between electron. Okay, so bila repulsion between electron tu kuat, that means shielding effect dia tinggi. So size yang mana lagi besar? So size P3 minus lebih besar lah. So that's why sudden increase dekat sini. So disebabkan shielding effect in P3 minus lebih tinggi berbanding silicon 4 plus. So if you want to see the difference, okay, kamu boleh tengok dekat sini. So ini silicon punya size in picometer, this is P3 minus punya size. Okay, different dia sangat besar. Okay, kalau soalan tanya kenapa? Why there is sudden increase between silicon 4 plus ion to P3 minus ion? This should be your answer. Conclusion. Okay, sebelum kita stop. The size of atoms depend on the electron cloud, the average distance of valence electron from the nucleus. Yes, that is right. Okay, so kalau kamu perasan semua explanation saya akan cakap bila attraction antara nucleus and valence electron getting stronger, that mean the distance antara nucleus and valence electron tu akan jadi makin dekat. Bila dekat, maksudnya size tu akan jadi makin kecil. Okay, alright. So, 3 important factors here. Okay, so kalau saya mention about ada tinggi electron repulsion ataupun shielding effect tinggi, that means the size of the atom will be larger lah. Sebab you can imagine the electron is pushing each other. So, size tu akan jadi makin besar. Tapi kalau ada nucleus electron attraction, the size will be smaller because the nucleus is attracting the electron towards itself. Okay, so size tu akan jadi kecil. Kalau principal quantum number n pula, dia kata as n increases, the average distance of valence electron from the nucleus increases, making the atoms larger. Okay, so kalau banyak shell, n tu shell lah kan. Okay, lagi banyak shell. So, maksudnya lagi besar jarak antara valence electron dengan nucleus. Okay, so size tu jadi makin besar. Alright, so that's all for this video.